My name is Jalen Cox, and this is my presentation on global warming and mammal detection.
It's nothing, guys, just a hoax perpetrated by pranks and climate scientists in a vast worldwide conspiracy.
Global warming. But unfortunately, for that penguin, it is not just a hoax. Humans are disrupting the natural balance in the carbon cycle by extracting and burning fossil fuels, which causes carbon and other greenhouse gases to accumulate in the atmosphere at higher rates than would naturally occur. Climate change has produced several threats to wildlife, such as rising temperatures, lowering many species' survival rates due to change that lead to less food and therefore less successful reproduction, and rising temperatures changing the natural distribution of species, which disrupts ecosystems and contributes to the loss of biodiversity. Climate-induced stress on native species could also facilitate supplementation by invasive species. And in the case of the snowshoe hare, environmental changes will possibly affect survival rate, at least for a time. So what are the unknowns? Are populations living at the southern or northern extent of their range more likely to decline or increase in population size due to climate change? Will all mammals of all species be similarly affected, or are certain species or groups more adaptable and therefore less likely to suffer decline? And how might the decline of these species affect their community at large? So the objectives. Understanding possible trends that may occur at the population level at the northern and southern extent of a mammal's range. Understanding how climate change could potentially negatively affect certain mammal populations while positively affecting others. Understand how future distributions could be estimated by correlating climate factors with mammal data from previous years. Understand the detection rate can be used to extrapolate relative abundance of a species in an area. So the methods. Several species were chosen with good camera data. The ray level occupancy and slash abundance were calculated for sites over 2+ years old in the United States. Over 2 years in the United States. Population trends were estimated based on detection rate, and studies were broken down into northern, southern, and middle latitudes. Latitudes. Hypothesis, or the hypothesis I was going forward with. Generally, the species living at the northern extent of their range's population size will decrease more so due to climate change than populations of the same species at the southern extent of their range. Here were some of the results. So for the American bobcat, you can see that it's pretty stagnant. It's a pretty stable looking graph, with in northern areas decreasing a bit more, but similar situation with the coyote, very stable looking graphs, but in the south it seems to be on the increase, at least slightly. White-tailed deer, once again, very stable. Black bear, like the coyote, increasing in its southern range, but staying pretty stable, although it does seem to be dipping a little bit in the mid and northern latitudes. The northern raccoon being once again a very stable species. The eastern gray squirrel, also very stable, with maybe some slight declines in the north and mid latitudes. And lastly, the Virginia possum, once again, very stable. What does this mean? Discussion. Detection rates don't always equal abundance, but show relative abundance, presuming that samples of low activity offset those of very high use. And data shows that the detection rate for selected species was similar in the north, south, and middle of the ranges. Some showed slight declines and others inclines, as I explained, but others didn't show either. I just chose 8 species, but this was the trend for most of them. And it is possible that this data may be skewed based on locations that these camera traps were set, perhaps being in areas of low animal activity, such as next to hiking paths or in near urban areas, or that the same individuals may appear several times in the data, may appear several times. Uh, this has been my presentation. Thank you.